In this video, you are going to learn about significant figures. Let's get started. If I ask you, how many significant figure is this number? Well, that is 1 because there's only one number here. How many significant figure is this number? We count for it, 1 and 2. So there are 2 significant figures. How about 476? How many significant figures? Let's count. 1, 2, 3. So 3 significant figures. How about 8254? How many significant figures? It will be 1, 2, 3, 4. 4 significant figures. When there is no zero in the number, everything seems easy. Just count and see how many numbers, and that will be the number of significant figures. However, that's not always the case. Sometimes you will see a zero somewhere. For example, 305. You will see a zero over here, and this will be considered as a 3 significant figure, or the captive zero will count as a significant figure. Captive zero means the zero that is in between 2 non-zero numbers. Okay, so let's summarize, see how we can count for the significant figures. Okay, we just have seen the non-zero digits. So how about the zeros? So this is already the summary, but let's look in detail. Captive zeros over here, for example, 3090, this zero is in between 2 non-zero digits, so it counts as a significant figure. This zero over here in between 8 and 2, so it is the captive zero. It will count as a significant figure. Now, let's look at the trailing zeros. That means the zero that is at the end. All the zero at the end before the decimal point, when there is no decimal point here, this zero will not count as a significant figure. For example, just look at this one, 3090, 3090, because this zero is at the end. So we will not count for it, and this one, we have 3 significant figures. Let's look at the other one, 500. These are the trailing zeros at the end without any decimal point. That means this one only has 1 significant figure because the zero at the end, it doesn't count. But we cannot just say this number equal to 5 because this 20 here is the 100 digit. That means it means 5 times 100 is 500. So these two are not equal, as obvious. However, some of the zeros at the end of the number that is after the decimal point, look at this one, 0.5 and 0.50. The value is the same. However, the number of significant figure is not the same. If someone write a number like this zero, they purposely write at the end in order to indicate the significant figure. So in this case, all the zeros at the end after the decimal point will count as a significant figure. So in this case, 0.5, there's only 1 significant figure, and 0.50, it has 2 significant figures. How about 0.500? Look at the number over here. These 2 zeros over here, it doesn't change the value of it, but it will change the number of significant figures. A person write it with these 2 zeros at the end means it should be significant to this digit, and therefore the zero at the end after the decimal point will count as a significant figure. So it's 1, 2, 3, 3 significant figures. The zero in the front, when there's a decimal point, that is the leading zero, and it doesn't count for the significant figure. Let's look at this number, 0.5040. How many significant figures? Let's look at this one. This 0 at the end is purposely put it here, try to indicate it is significant. So this one we have 1, 2, 3, 4. 4 significant figures. The leading 0 in the front of the decimal point will not count. So all these things will not count. All these zeros will not count. Okay, so let's look at this example. Let's do more exercise. How about 470? How many significant figures? This one will be 2 significant figures, no decimal point, and there are 3 numbers here, but this 0 is the trailing 0. Without decimal point, it will not count. How about 4700? How many significant figures? In this case, still 2 significant figures. So the question is, how do I write this if I insist to have this one to be a 3 significant figure? How do I do that? I cannot just put a decimal point here. That introduces us to something is called scientific notation. Scientific notation. It must be written in the form of a times 10 to the n power, where a is between 1 and 10. For example, in this case, I can write this number if I want 3 significant figures. So a will be equal to 4.70. 4.70, that will times 10 to the 3 power. In this case, n is an integer. It can be positive, it can be 0, and it can be negative, but it's an integer. All right, let's look at this one. When it is written in the forms of scientific notation, how many significant figures? It depends on this number a here only. So this number has 3 significant figures, and therefore the whole number over here will be 3 significant figures. Okay, so the question will be, can I write it this way? Can I write 47 times 10 to the 2nd power? The value is the same. However, we cannot write it like this because this number is not between 1 and 10. The a value over here, it must be between 1 and 10. So how do I express in scientific notation to have a 2 significant figure? Then it will be 4.7 times 10 to the 3rd power. That's how we express this number to a 2 significant figure in scientific notation. Okay, let's see how we can use significant figures to do calculations. The first calculation will be addition and subtraction. Let's look at the rules. When we add or subtract numbers, we should round the result to the same number of decimal places as the number with the least number of decimal places. What do I mean by that? Let's say if I measure my weight and let's say it's 189 pounds. If I suddenly put a ring on it, my ring is about 0.007 pounds. Okay, so what should I write if I have to fill up a form? Should I write, you may say, when you add them up, it must be 189.007 pounds. However, we are not going to write something like this because there are too many decimal numbers over here. We should keep the least number of decimal points. Okay, so in this case, it will be still 189. Let's do another example. If I have 0.127 and if I add 0.00002 to it, what should I get? Let's say it is grams. Okay, which one it is the least number of decimal places? It will be over here. It is just 1, 2, 3. 3 digits after the decimal. So what our result will be, we are going to keep it only to here. That means supposedly we should have 127,002, but we are not going to write it that long. We are going to keep it 3 digits after the decimal point. So for addition and subtraction, we will follow this rule. How about multiplication and division? Let's look at the rules. When we multiply or divide numbers, we should round the result to the same number of digits as the number with the least number of significant figures. What do I mean by that? Let's say we have 1425. Let's say we measured an area that is in inch, and that's the length, and the width, let's say, is 46 inch. But when we try to get the area, that means we have to multiply these two numbers. This one is how many significant figure? It will be 1, 2, 3, 4. 4 significant figure. The one below, it has 2 significant figure. When we do multiplication or division, we only look at the least number of significant figure. That means as for our result, we should expect to have a 2 significant figure answer. If I just multiply these two numbers, what I will get is, I just use my calculator, I punch in 1425 times 46. My calculator shows me that I get 65550. Let's see how many significant figure this number is. It has 1, 2, 3, 4, only 4. The 0 at the end doesn't count as a significant figure in this case. So I cannot just put the answer like this. I have to put it based on the least number of significant figure, which is 2. So when I multiply these two numbers, strictly speaking, I can only put it to be 6766000. 66, we round this off to become 6 over here. So that is 2 significant figures. As for division, it's the similar thing. So let's say we have 1425 divided by 46. How many significant figures do we expect for our answer? It will be 2 significant figures. So 1425 divided by 46. I get my answer is 30.98 and on, 97 and on. But how do I express this number as a 2 significant figure? You can either write it as 31, or you can say 3.1 times 10 to the first power. Okay, is there any exceptions when we do multiplication and division? The answer is yes, there are exceptions, and that is called the exact number. What is the exact number? The counting number we count as exact numbers. For example, if my measurement, what I have is 154 cm, let's say I try to measure my height, and the other one is 156 cm. I want to know the average. Okay, average, I can add this up and then divide it by 2. So in this case, this 2 is the exact number, it's counting number. So what we have over here on top, we are going to have 310, and divided by 2, we cannot say our answer should have 1 significant figure because we are dividing by a 1 significant figure. In this case, counting number would not be part of our significant figure consideration. So this case, we can have that is equal to 155. When we do unit conversion, the conversion factor will not be part of the consideration for significant figure. For example, I have 4914 cm and I want to convert it into inches. So here I start with a 4 significant figure, and the answer over here, it looked long, but we have to put it back to 4 significant figure, that is 1937. And this conversion factor will not be part of our significant figure consideration.